Alright, so here are the very last problems in our worksheet, and this will probably be the last problem on your test as well, if I'm guessing correctly, and not totally because I've seen the test and know exactly what's on it. But anyways, these again are they're just asking us to solve these right triangles, and they want all angles and all sides. All angles and all sides. That's what they mean by solve. So the weird thing about this problem is that they don't give us the triangle yet, they just give us these coordinates. So for instance, J is 1, 2, 1, 2, 3. Here's J. K is negative 1, 1, 2, 3, 4. There's K. And L is negative 1, 1, 2, 3. So we have this right triangle still, but it's on a graph instead. And what's cool about this is that we can see our right angle, right? It's the perpendicular lines. And we can also see exactly how long two of the sides are. So J is 1, 2, or sorry, LJ is 1, 2, 3 long. And LK is 1, 2, 3, 4, 5, 6, 7 long. 7 long. So we have this triangle with side lengths 3 and 7. Now we know if we don't have an angle, we can find this third side by doing Pythagorean theorem. And they were nice enough to make the hypotenuse C. The hypotenuse is C. They were nice enough to not give us that angle. That side. So we're just going to solve for C then. So 7 squared plus 3 squared equals C squared. That'd be 49 plus 9 equals C squared, and 58 equals C squared, and C is the square root of 58, and we can actually just type that into our calculator because they didn't ask us to leave it in simplest radical form. So square root of 58, 7.62, because they want us to round it to the nearest hundredth. 7.62 would be our answer for that one. Now what about if we wanted to find the angles? Well, we already have angle L. Angle L is 90 degrees, right? But what about angle J or angle K? Well, we have the side lengths, so we can use those to our advantage. We can use those when combined with SOHCAHTOA to find the angle lengths, or the angle measurements. So if we're looking at angle J, 3 is the adjacent and 7 is the opposite. So we have O and A. We're going to use TOA. All right, so for angle J, we can do the tangent of J is opposite 7 over adjacent 3. The tangent of J is opposite over adjacent. And then since we're solving for an angle, we're just going to do inverse tangent. So J is inverse tangent of 7 over 3. And we just plug that into our calculator. Second tangent of 7 divided by 3. They want it rounded to the nearest degree, so we get 67 degrees. J equals 67 degrees. Well, to find K, we can do the exact same thing. I'm actually going to put that in a box. Never put K in a box, but you know. This side 3 is opposite, and this side 7 is adjacent. So notice we're just going to use tangent again, but it's going to be flipped. So the tangent of K is opposite 3 over adjacent 7. And we're going to do inverse tangent to solve for the angle K. So inverse tangent of 3 over 7. Well, now that we have K alone, we just plug it into our calculator. So second tangent of 3 over 7. We can get 23 when we round to the nearest degree. So K is 23 degrees. Now if we look right next door, here's another example, and it's the exact same thing. We're just going to plot our points first. So negative 1, 2, 3, 4, 5, 1. This is M. N is 1, 1. There's N. And P is negative 5, 1, 2, 3, 4, 5, 6, 7. Right here. Here's P. And here's our triangle right here. So angle M is our 90 degree. We can see that those perpendicular lines. Well, from M to P is 1, 2, 3, 4, 5, 6. And from M to N is 1, 2, 3, 4, 5, 6. Well, that's interesting. This looks a lot like a triangle I've seen before. Well, if these are the same, these legs are the same, then these must also be the same. I know they're 45, these angles. I also know that the hypotenuse is the leg times the square root of 2. There's a 45 angle. And there I'm done. So for these, it's important just to remember about our 45, 45, 90 triangles. And so I'm going to give you just a quick refresher. If we have a 45, 45, 90, well, its angles are congruent, so the sides will be congruent. They'll be x, if you will, and that x could be any number, like a 6. And the hypotenuse is just that leg times the square root of 2. Square root of 2. And just as a quick refresher as well for our 30, 60, 90s, if I had a triangle that was 30 degrees and 60 degrees on the other angle, then the short leg would be across from the 30-degree angle, and it would be x. The long leg we could find just by timesing the short leg by the square root of 3. And then the hypotenuse would be that short leg times 2.